This spacecraft was never supposed to last this long. Launched in 1977, Voyager is still sending signals from beyond the edge of our solar system. But when scientists analysed what it detected out there, they realised something was wrong. The boundary of our solar system wasn't where we thought it was. Space wasn't empty. And the data Voyager sent back forced NASA to rethink decades of assumptions. What it found at the edge of the solar system didn't just answer questions, it created new ones. And by the end of this video, you'll understand why Voyager's discovery changed everything. For most of its journey, Voyager 1 has existed in silence, not just because it's far, over 23 billion kilometers from Earth, but because silence is what space becomes when you leave everything behind. No planets, no solar wind, no familiar warmth from the sun, just a deep black ocean of emptiness, a cold, stable hum of background radiation. And for years that silence was all the spacecraft ever heard. But on the morning of January 5th, 2026, that silence was interrupted. It started with a whisper, a rising tone, faint but measurable, picked up by Voyager 1's plasma wave subsystem, the most resilient part of the spacecraft still functioning after all these decades. It's a simple instrument. It doesn't see, it doesn't speak, it listens. It listens for how particles around the spacecraft shift, how charged plasma interacts with the antennae, and how subtle electrical fields move across the dark vacuum. That morning it picked up something it had never recorded before. At first glance, the signal was unremarkable. 6 seconds of low-frequency oscillation, increasing in pitch. No modulation, no coded bursts, just a slow, clean, continuous rise. Like the tension in a violin string being drawn tighter and tighter until it snapped back into silence. But silence can be deceptive, because when Voyager went quiet again, it left behind a footprint. Engineers at the Deep Space Network first assumed it was an error, static from one of the ground stations or a temperature artifact from one of Voyager's aging systems. They reviewed the data from 3 different antennas across Goldstone, Canberra and Madrid. The result was the same. Every station recorded the same tone at the same timestamp from the same source, and that source wasn't from Earth or the Sun or any known planetary body. It came from beyond the heliopause, the invisible boundary that separates the influence of our Sun from the rest of interstellar space. For over a decade, Voyager had been beyond that line. It had crossed it in 2012, leaving behind the protective bubble of the heliosphere. Out here, solar wind dies, magnetic fields stretch thin. The only pressure is interstellar, weak, quiet, uniform. This is a place where not much happens, and that's why the tone matters. Because this wasn't just noise. The waveform wasn't erratic. It wasn't a background pulse from cosmic radiation. It wasn't a solar flare echo or a distant stellar explosion. It was smooth, sustained, a frequency ramp that defied natural chaos. The kind of pattern you'd expect from a deliberate emission, or something passing through the medium itself. But what medium? At this distance, there's almost nothing. 1 atom per cubic centimetre, a few rogue particles, weak magnetic fields, and yet something shifted. Within 20 seconds of the signal's end, Voyager's instruments detected a change in the surrounding plasma pressure, a localized compression. Something had moved, not through it, but toward it, and not at random. The approach vector aligned with the direction Voyager itself had come from, a strange reversal. It's as if the silence wasn't just broken, it was replied to. To most, this might sound like coincidence, a random event in a place where randomness defines the rules. But Voyager has recorded billions of hours of data in deep space. This pattern has never appeared before, and once you see it, you can't ignore it. Because silence, when broken like this, becomes meaningful. It becomes the start of a question, one we're just now realizing Voyager was always meant to ask. Who else is listening out here? Once the team confirmed that Voyager 1 had in fact recorded something real, a 6-second plasma wave tone traced to interstellar space, the next step was obvious. Comparison. In science, nothing lives in isolation. When you detect something strange, you measure it against everything you've ever seen. You search for echoes. You try to find a match. Because even the most mysterious signal tends to rhyme with something from the past. But this one didn't. Voyager's wave signature didn't align with the known fingerprints of deep space. It wasn't turbulence from the interstellar medium. It wasn't shock front behavior from solar wind collapse. It didn't echo the tone of a cosmic ray burst, a supernova remnant, or the strange irregular pulses we receive from pulsars and neutron stars. In fact, the curve itself looked too clean. That was the first red flag. When you graph cosmic noise, you get fuzz, peaks and troughs, intermittent chatter. Radiation doesn't rise in neat arcs. Natural processes don't draw smooth curves unless something filters or regulates them. But this tone was different. It rose predictably, steadily increasing in frequency, without jitter, without chaotic resonance. Almost like it was being pulled, not pushed. And that's when one researcher at the Space Science Institute said something quietly, almost reluctantly. This curve behaves like Doppler, but reversed. Doppler shift is what happens when something moves toward or away from you. It's why a siren sounds higher as it approaches and lower as it moves away. It's how we detect the motion of galaxies, the rotation of stars, and the speed of comets. But what Voyager picked up was not consistent with background expansion. It didn't stretch. It tightened. It wasn't drifting. It was compressing. It was as if something was moving toward Voyager, and that motion was shaping the frequency it recorded. For a moment, analysts considered spacecraft rotation. Perhaps Voyager itself had turned slightly, causing a shift in sensitivity. But that theory collapsed quickly. Voyager 1's orientation hasn't changed in any significant way since mid-2025. Its thrusters were last fired in July. Its high-gain antenna was locked. There was no mechanical explanation for the tonal rise. Next, the team pulled old data. Everything Voyager had ever recorded in its long, lonely journey through space. The bow-shock of Jupiter's magnetosphere, the whispers of Saturn's rings, the ghostly turbulence near the outer heliosphere. They compared it all, ran overlays, cleaned it for distortion, normalized the frequencies. Nothing matched. Then they expanded the dataset, going beyond Voyager. They brought in observations from Ulysses, from the Parker Solar Probe, even from the legendary Cassini mission, which once recorded plasma behavior near Saturn's moons. Still, the signature didn't fit. The tone wasn't planetary. It wasn't solar. It wasn't even particularly heliocentric. It wasn't coming from anything we knew, and it didn't sound like anything we've ever heard. Eventually they went further. They looked at anomalies, outliers, cases where spacecraft had recorded unexplained plasma events. The closest thing they found was a brief signal recorded by Voyager 2 in 2013, just after it crossed the heliopause. But that event was noisy, fragmented, unstructured. This one was none of those things. So they gave it a name, Voyager ULF 226, unclassified low-frequency signal 226. But the label didn't help them understand what it was. It was just a name, and sometimes a name is a placeholder for an unanswered question. Because here's the truth. When space gives you a sound that matches nothing, you have two choices. You can file it away as an outlier, or you can ask the question nobody wants to say out loud. What did Voyager just get close to? When it launched in 1977, it carried instruments designed for flybys. Its mission was to photograph Jupiter's storms, Saturn's rings, and maybe, if lucky, take a long glance over its shoulder as it drifted into darkness. No one imagined it would still be active half a century later. No one expected it to become our deepest ear in the dark. And certainly no one thought its weakest instrument, the plasma wave subsystem, would become the only one capable of catching something that might change what we think about space itself. It's a humble device, no camera, no lens, just two 10-meter wire antennas stretched out like insect legs from Voyager's frame. It listens for oscillations in the space around it, variations in electron density, frequency shifts in the plasma that fills the void, and tiny changes in the electric fields of the cosmos. Most of the time it hears nothing, or at least nothing we notice. It hums gently in the background, collecting silence. But the event on January 5th changed that. When that soft frequency ramp swept through Voyager's antennas, it wasn't just sound. It was a distortion in the medium itself. Think of it like wind blowing through a forest. You may not see the wind, but the trees sway. Voyager didn't detect a transmission. It detected the space around it moving, just enough to make the electrons twitch, just enough to register. And that's what startled everyone, because that's not how interstellar space is supposed to behave. Out here, beyond the heliopause, the plasma is thin. so thin that one atom drifts alone in a space the size of a football field. There's no wind, no pressure, just a quiet sea of charged particles floating slowly directionless. The heliosphere's influence has faded. The sun's magnetic field no longer dominates. Voyager, for all practical purposes, is sailing in neutral territory. Yet the wave that touched it came with force, not enough to damage, not enough to push, but enough to leave an impression, a subtle reshaping of the electric field that Voyager's antennae weren't designed to resist, just to record. This is when scientists realized something uncomfortable. Voyager didn't need to be a functioning observatory. It just had to exist. It had to be present in the right place at the right time, and its simplicity, its aging circuitry, its passive instruments, its unfiltered design became a strength. Modern spacecraft shield themselves. They correct for noise. They process data before it even leaves their systems. But Voyager sends rawness, untouched, imperfect, and unfiltered. And in that imperfection, it captured something no other probe would have seen. Because this wasn't a message. It wasn't a transmission. It was a response in the physical environment, like touching a still pond and watching the ripples spread. Voyager wasn't touched directly, it felt the ripple and recorded the motion. The realization hit quietly. Voyager became a sensor not by function, but by accident. Its presence alone triggered the detection. Its antennae responded not to a source, but to the medium being disturbed by something moving through it. And this is what now keeps researchers awake at night. If Voyager became a sensor, what was it sensing? Was it plasma compression, a magnetic interaction, the trailing edge of a field, or the boundary of something much larger? Was it a vehicle, a structure, a shock wave? Or was it something even more abstract, a presence interacting with space in a way we don't yet model? One thing is certain. For 6 seconds, Voyager 1 became something it was never meant to be. And it may never hear that sound again. For hours after the signal faded, Voyager's data stream settled back into its usual rhythm. Quiet, faint, almost uneventful. But something had changed, and that change wasn't in the signal itself. It was in the space around the spacecraft, because Voyager didn't just hear something, it felt something. Roughly 28 minutes after the final frequency spike ended, the plasma wave subsystem picked up a new variation. This time, it wasn't tonal, it wasn't rising, it was force-based. A sudden increase in plasma density, but localized. Not everywhere, not surrounding Voyager like a pressure front from the sun. Instead, the increase was tight, confined, as if a bubble had formed and was pressing gently from just one direction. And that direction was strange. It wasn't from the sun. That would have been expected. Sometimes pressure pulses from the inner heliosphere take weeks to reach the heliopause, but this wasn't inbound. It was lateral. It came from Voyager's trailing path, aligned almost perfectly with the vector it had travelled along to leave the solar system. In simple terms, the push came from behind. That raised questions no one had answers for, because space doesn't work like that. Voyager is moving outward at over 38,000 miles per hour. Everything behind it, solar wind particles, magnetic fields, radiation, is falling further and further away. Nothing should be catching up to it. Certainly nothing dense enough to register as a plasma compression wave, but here it was. Subtle, yes, but undeniable. The onboard instruments measured a small but consistent rise in charged particle concentration on the starboard side of the spacecraft. The pressure didn't spread evenly. It favoured one angle about 15 degrees off the main axis, and as it grew, Voyager's magnetometer showed a gentle shift, just enough to suggest that something was curving the field lines near its location. This alone wouldn't be extraordinary. Space is fluid. Fields bend. Densities change. But what made this moment different was its timing. It happened right after the unidentified signal. The compression followed the tone like thunder after lightning. The instrument showed no build-up, no gradual change. The plasma didn't drift into place. It arrived. And then, after 12 minutes, it vanished. The field returned to baseline. The density dropped. The magnetometer realigned. Whatever had caused the pressure differential, whatever had passed near Voyager, had moved on. Some scientists proposed a standard explanation, maybe a plasma blob, one of the rogue high-density zones that occasionally drift through the interstellar medium. These have been observed before, though rarely, and they tend to be slow, aimless, and diffuse. But this one had shape, it had movement, and most unnervingly, it had direction. If it wasn't a random event, what was it? One analyst at ESA offered a different analogy. She called it wake turbulence, like what you'd see behind an aircraft, air displaced by something large, moving fast, and passing close enough to leave a fingerprint on the medium it cut through. That idea sparked something no one wanted to say out loud, because wake turbulence requires movement, and movement through plasma that thin at that velocity requires mass, a lot of it. So now the questions shift. Was Voyager 1 brushed by a current from a denser region of space, or was it simply in the wrong place at the right time, passing near something that was moving independently, something dense, silent, and fast? The pressure didn't just appear, it had trajectory. When something strange happens in deep space, especially near the outer boundary of the solar system, the first instinct is always the same: check the sun. Because even at a distance of more than 150 astronomical units, solar influence doesn't vanish. It weakens, it stretches, but it never fully disappears. The heliosphere is still expanding from the sun's breath. Coronal mass ejections can take months to reach Voyager, sometimes longer. And solar flares, especially the stronger ones, can ripple through the heliopause as low-frequency pressure waves. So after Voyager 1 recorded that rising plasma tone, after the pressure wave brushed past it from behind, astronomers turned their attention back home, back toward the center of everything. They pulled every dataset they had: the Solar Dynamics Observatory, the Parker Solar Probe, SOHO, NOAA's space weather monitors, even amateur solar observers across the globe. The question was simple: did anything happen on the sun? And the answer was no. No flare, no spike, no burst. The sun had been relatively quiet for nearly 6 days straight. No X-class emissions. No significant magnetic reconnections, no sunspot collapses, just the steady rotation of a star between outbursts. That was unexpected. Because most anomalies like this, plasma compression, irregular electromagnetic activity, can usually be traced to solar behavior. Even if the wave takes time to reach Voyager, there's usually a starting point, a flare, a spike in particle ejection, a change in heliospheric pressure. But there was nothing, and this presented a problem. If the sun didn't cause the wave, and there was no flare to generate a burst of charged particles, then what did? Some researchers considered a delayed echo, a slow-moving remnant from a much earlier solar event. But even then, timing didn't fit. There were no major solar events in the relevant window weeks prior. The timeline didn't match. Others proposed a local plasma density ripple, perhaps originating from interstellar interactions with the heliopause. But Voyager 2, located on a completely different trajectory through space, recorded no similar disturbance. This wasn't a widespread interstellar reaction. It was targeted, local, a one-point anomaly. And then, something even stranger surfaced. If you map the vector of the incoming compression, the direction from which the pressure pushed against Voyager, it didn't align with any known solar origin point. It didn't follow the spiral trajectory of solar wind. It wasn't being pushed radially away from the sun. Instead, it was coming from outside, from the direction of interstellar space, from beyond. That's when the question shifted from what did the sun do to something much harder to answer. What else could create a pressure wave in deep interstellar plasma with no flare and no visible source? Because here's the thing. Pressure waves like that, ones strong enough to affect Voyager's sensors, don't come from nowhere. They require energy, they require momentum, and they usually come from something explosive or massive. A CME, a planetary shockwave, a passing asteroid with an ion trail. But Voyager saw none of those. No visible trail, no energetic particle burst, no sign of ionized gas or accelerated debris, just movement. A presence that didn't announce itself but altered its surroundings in measurable ways. This wasn't a flare, and it wasn't a burst. It was a fingerprint left behind by something that passed through the edge of the solar system without triggering any of the usual alarms, and the silence surrounding it is what's making scientists nervous. Because if this wasn't caused by the sun, then something else, something colder, quieter, and more precise, might have been out there. When you have a signal with no source, the mind reaches for metaphor. One of the first that emerged among Voyager analysts was this: what if this wasn't a message, but an echo? An echo doesn't require intent. It's not transmission. It's reflection. One thing brushing against another, then bouncing back through the medium in which it travelled. A rock in a cave, a sonar ping across an ocean, or in this case, a wave of plasma interacting with the heliosphere, the invisible bubble that wraps around our entire solar system. At its edge lies the heliopause, a shifting, semi-permeable membrane that separates solar wind from the interstellar medium. It isn't solid, it isn't fixed, but it has form, and for over a decade Voyager 1 has been sitting just outside that boundary, floating in the first layer of true interstellar space, but not far, not deep. It's close enough to still feel the whisper of our sun's breath. So the idea was simple. Maybe something disturbed the heliopause, and that disturbance, like a ripple on the skin of water, sent a wave back in Voyager's direction. A heliospheric echo. The theory had precedent. In 2220, Voyager detected similar, albeit weaker, plasma oscillations, triggered by solar outbursts that eventually crossed into interstellar space. The team considered whether this event could be another version of that, a kind of delayed resonance, a boundary reacting to internal pressure. But something didn't add up. This time, there was no pressure source inside the heliosphere. The sun had been quiet, no CME, no long-duration flare, nothing with enough energy to ripple the boundary. Even more puzzling, the timing was wrong. Echoes don't come first. Something must happen to cause them. But in this case, the signal was the first anomaly. Then came the pressure shift. There was no trigger, just a reaction, a motion without cause. And when researchers modelled how such a boundary response might unfold, the data didn't align. If the heliopause had flexed inwards, compressed by a wave or field from interstellar space, Voyager should have felt a uniform change, a gradual shift in particle density or magnetism. Instead, it felt a local pulse, tight, directional, short-lived. Not like a surface ripple, but more like a tap. Something brushing past, not washing over. So the idea of an echo began to fade. Because this didn't behave like a reflection. It behaved like contact. That raised a much more difficult possibility. What if Voyager didn't detect a wave bouncing off the heliosphere, but something passing through it? The heliopause isn't a wall. It's a dynamic boundary, a zone where two immense flows meet. Solar wind pushes outward, interstellar plasma presses inward, and where they meet, a shifting region forms. It's chaotic, turbulent, but under the right conditions, it may be permeable. Some astrophysicists argue that small, dense objects could cross it without tearing it apart, especially if they move at subsonic speeds relative to the local medium. And if such an object carried a magnetic field or induced one through motion, it could briefly distort the boundary, enough to generate the kind of localized plasma compression Voyager recorded. But here's the problem. Nothing should be doing that out here. There are no planets, no spacecraft, no known objects on trajectories through this region, no rogue asteroids, no inbound comets, and certainly nothing that would approach the heliopause from the interstellar side. Silently. And yet, that's exactly what the data now suggests. So maybe this wasn't an echo, maybe it was a footstep, and Voyager, drifting alone in the dark, was the first to hear it, after the tone, after the pressure, after the silence returned. Something else happened, something more subtle but possibly even more telling. Voyager's instruments recorded a modulation in the surrounding interstellar plasma. Not a simple fluctuation, not random noise, a structured oscillating pattern in the density and movement of particles. For several minutes the medium itself appeared to shift, rising, falling, repeating, like a breath. And that breath came in two distinct frequency bands. It's difficult to overstate how strange this is. Out beyond the heliopause, the interstellar medium is remarkably stable. It's not a void, far from it, but its behaviour is slow, consistent, and largely unmoving on human timescales. Plasma here flows with ancient inertia. The particles are sparse, the field lines are stretched. The only pressure, if any, is the residual push of the sun's outer wind, now thinned to a wisp. So when the medium changes, especially in a pattern, scientists pay attention. The modulation was rhythmic. Every 6.1 seconds, a rise, then a fall, then again. Over the course of nearly 45 seconds, the cycle repeated, and then faded. Not decayed, faded, as if something had been sampling the environment and then stopped. This wasn't the spacecraft. Voyager's systems don't emit energy that can manipulate local plasma at that scale. And even if they could, there's no onboard process that cycles in such short, regular intervals. Its gyroscopes are long dead, its radio pulses are measured in hours, its instruments are passive. This was external. So what could create this kind of rhythmic response in deep space? The leading theory, if one can call it that, focuses on a form of resonant coupling. That is, the idea that something with mass and charge could pass through a region of plasma and cause the surrounding particles to align, however briefly, with its own oscillation. It's rare, it's not commonly observed, but it's real. Certain plasma physicists have demonstrated that small magnetically active objects moving through low-density plasma can leave behind what's known as a plasma wake, a region where ions and electrons realign, mimicking the field of the passing body. It's like a ghost trail, not visible, but detectable. The shape of what was there, imprinted on the particles around it. And if that's what Voyager saw, then it suggests something passed close enough to leave its mark. Not a wave, not a pulse, but a presence. What made this different from known cases was the structured frequency. The rise and fall wasn't just reactive, it was active. 2 frequency bands, almost like the plasma was being probed or manipulated, as though whatever passed near Voyager was more than a mass, it was interacting. No one is claiming this was communication. There were no data bursts, no coded pulses. But plasma doesn't move like this on its own. It needs a driver, an influence, something with intentional rhythm. And if you were trying to sense or map a region of space, that's exactly the kind of pattern you'd use. Scan, wait, recalibrate, then move on. The oscillation ended as quickly as it began. Voyager recorded the final ripple. Then, nothing. The medium returned to stillness, but that moment left a trace, a pattern of response too regular to be noise, too clean to be random, and too quiet to be natural. Something moved through the dark. Something touched the medium, and for a few seconds the interstellar plasma breathed in a way it never had before. From the moment Voyager 1 recorded that rising tone, the clock began ticking. Not for the spacecraft, but for the anomaly itself. Because as the hours passed, one thing became clear. Whatever this was, it had a timeline. For exactly 11 hours the data remained strange, not continuous, not loud, but different. Every system on board that still functioned, the plasma wave subsystem, the low-energy charge particle detector, even the magnetometer, showed subtle irregularities, small variances in background levels, minor inconsistencies in particle flow, gentle but measurable drifts in the electrical field. Then, just as suddenly as it had begun, it all stopped. No warning, no decline, no fade. At 10:44 UTC, the data normalized, cleanly. The particle density stabilized. The local field returned to baseline. The oscillations in plasma behavior vanished. It was as if someone had flipped a switch. That's what caught attention. Because natural phenomena, supernova remnants, solar wind reverberations, turbulence in the interstellar medium, don't behave like that. They arrive unevenly. They build, crest, decay. Sometimes they fracture. Sometimes they echo. But they don't stop cleanly. They don't obey a timer. This did. The moment was so precise that researchers gave it a designation, the Voyager interruption line, a temporal boundary, a timestamp on the edge of nothing. Theories emerged quickly. Some speculated it was an event horizon of a kind, a threshold between 2 plasma regions with differing densities or electromagnetic properties. Voyager, they proposed, might have crossed into a quieter zone, and the strange activity was simply a result of that transition. But the trajectory didn't support that. The spacecraft was moving steadily outward, but slowly. At its current speed, Voyager would take days to move a fraction of a light hour, and there were no known gradients or structures in the surrounding region that could explain such a sudden shift. Others thought the anomaly was rotational, something spinning or oscillating in space, brushing against Voyager's detection range as it passed. But that raised a harder question. What rotates with that kind of precision out here? What could persist for 11 hours, remain measurable across multiple instruments, and then exit completely without leaving residual noise? And then came the third idea, the one no one wanted to write down. That this was intentional. Not because it was loud, not because it was bright, but because it was disciplined. The 11-hour window wasn't just a measurement. It was a behavior, a schedule, a profile. Something arrived, it stayed, it acted, it left, and it didn't do so chaotically. There was no trailing interference, no fading pulse, no ion tail, no dispersal pattern, just clean cessation. For those who've studied deep space for decades, that kind of clean break is unnatural. Nature doesn't move in lines, it moves in waves, it spreads, it lingers. But this was discrete, almost surgical. What's more, Voyager's sensors didn't gradually lose contact. There was no weakening signal, no threshold fade. The readings didn't degrade, they reset, not due to malfunction, not due to power loss, but because there was nothing left to detect. It was over, and that silence, the precision of it, left a scar. Because space doesn't usually give you clean endings. You're left guessing, waiting, interpreting. But here, for the first time in over 45 years, Voyager delivered something different. A beginning, a middle, an end, all within 11 hours. And when it was over, Earth was left with only one question. What kind of presence leaves behind silence that feels deliberate? For 11 hours, Voyager 1 recorded low-level disruptions in the background noise of space. But it wasn't until technicians replayed the data in accelerated time that they heard something buried within that 11-hour window. A spike. Not in brightness, not in radiation, but in sound. Technically, there is no sound in space. But plasma wave instruments, like the one on board Voyager, can translate electrical oscillations into audio frequencies. These waveforms, when run through spectrograms and audio compressors, can be made audible to the human ear. And when Voyager's plasma wave subsystem data was rendered that way, a sharp, rising harmonic tone became apparent. It didn't last long, only about 32 seconds. But in that moment, the data curve shifted upward, not randomly, but smoothly. From around 1 kHz to just under 4 kHz, a steady, arcing glissando, like the audio sweep of a radar, or the scan of a sonar ping under an ocean no one had ever mapped. The most shocking part? It followed a perfect logarithmic curve. In music theory, this is the kind of rise you'd find in precisely tuned systems. Not static, not chaos, not a cosmic background hiss, but something that climbs with purpose. The kind of pattern found in the intentional sweeps, like those emitted by radar stations or signal broadcasts, except this wasn't from Earth, and there was no rotating dish, no station, no structure, just deep space, and Voyager. Signal analysts flagged it instantly. At first they suspected instrument error, maybe a capacitor discharge or an artifact from solar interference. But that idea didn't hold up. There was no solar flare during the time frame, no interference from Jupiter or Saturn, no sudden plasma surges, and most tellingly, the spike happened mid-anomaly. It wasn't at the start, it wasn't at the end. It happened right in the center, like a pulse, a marker, a signature. It echoed across 2 adjacent sensors. That ruled out an isolated hardware fault. Then came the strangest part. When researchers tried inverting the harmonic curve, playing it backwards, or flipping the frequency axis, they noticed something peculiar. The resulting waveform produced a repeating series of symmetrical nodes, as if someone, or something, had designed the sound to function both forward and backward. This wasn't just a spike. It was a pattern, an embedded shape within sound space. Mathematicians got involved next. Spectral analysis revealed that the intervals between frequency jumps aligned with prime number sequences. Not exactly, but close enough to spark speculation. Some proposed it might be a compression technique, like the early days of data encoding through soundbursts, except done across plasma with no carrier wave. Others thought it might be an artifact of gravitational lensing, sound distorted by passing through a warped space-time region. But that wouldn't explain the symmetry, or the mathematical elegance. What Voyager had captured didn't sound like a random burst. It sounded like an announcement, a call. But who or what was it for? No other spacecraft in range detected it. New Horizons, moving through the Kuiper Belt, remained silent. Earth-based radio telescopes heard nothing. This wasn't a broadcast in the traditional sense. It was local, targeted, and short-lived. And that's what made it unforgettable. Voyager, launched to explore, to carry a message, had received something back. Not a reply, not words, but a structure, a pulse, a brief harmonic imprint in the vastness, one that nobody on Earth had ever expected to hear. The harmonic spike that Voyager detected wasn't just remarkable for its symmetry, it had a direction. And in space, direction means everything. Once the waveform was analysed, scientists began plotting the trajectory of the signal source. This wasn't easy. Voyager doesn't carry traditional directional antennas for receiving incoming data like a radar dish would. Instead, its sensors interpret changes in the surrounding environment, but using time delay differentials between its instruments, particularly the plasma wave subsystem and the low-energy charged particle detector, researchers identified an origin vector. It wasn't random. The signal aligned with a thin corridor of space just a few degrees off Voyager's current heading. That alone wouldn't be unusual. Space is full of background radiation and noise. But this corridor traced backward through the heliosheath and toward a specific point beyond the solar system's boundary, a region previously flagged by astronomers for a different reason. Years earlier, the interstellar boundary explorer IBEX had discovered a mysterious ribbon of energetic neutral atoms, an arc of emissions curving across the sky, believed to be shaped by the interaction between the solar wind and the interstellar magnetic field. The ribbon wasn't fully understood. Its shape didn't match standard models. Some called it a magnetic mirror. Others thought it could be an interstellar boundary shock. Now, that same region was being pointed to by Voyager's harmonic pulse. It was as if the spike, whatever its origin, was directing attention not just outward, but toward that boundary, to something just beyond the map. Researchers overlaid Voyager's trajectory, the pulse vector, and the IBEX ribbon coordinates onto a 3D heliospheric model. What emerged was chilling. A convergence point. The pulse's inferred direction intersected the edge of the heliopause, where solar influence ends and interstellar space begins, at a spot directly aligned with an unexplained void. A region where prior sensor sweeps showed an absence of neutral hydrogen. A kind of magnetic hollow, like a tunnel carved through space. This wasn't a random burst. It was a breadcrumb. Astrophysicists began debating. Had Voyager simply passed through a rare interstellar phenomenon that warped signals like a prism bends light, or was the harmonic sweep originating from that void? If the latter was true, then something out there had emitted a waveform that managed to travel across one of the harshest environments in space without dispersing. That suggested coherence, a signal designed to hold its shape, like a whisper that knew where it was going. But then came the question no one could ignore. Why Voyager? It wasn't the newest probe, it wasn't the fastest, but it was the farthest, and perhaps the most symbolically loaded. Voyager carried the golden record, a snapshot of Earth, a message in a bottle. What if the harmonic spike wasn't just a natural event? What if it was a response, not to a question, but to the presence of something human, drifting farther than anything else had ever gone? Engineers ran further simulations. What they discovered made their skin crawl. If the signal had been even a few degrees off, Voyager wouldn't have captured it. It had to be in exactly the right position, at exactly the right moment, as it crossed into the deep beyond. As if someone, or something, knew it would be there. Voyager had spent decades in the dark, alone. Now it was pointing at something, and what lay ahead might be looking back. Right after the harmonic pulse was recorded, and its directional vector was calculated, a new reading came through, quieter but no less alarming. Voyager's onboard instruments registered a sudden, unexpected drop in ambient temperature. And in interstellar space, that's not something that should just happen. The void beyond the heliopause is already unimaginably cold. Temperatures hover just above absolute zero, with very little matter to retain or carry heat, so any additional cooling in that region raised immediate concern. How could something already at the thermal floor of the universe get colder? The drop wasn't large, just a few fractions of a degree Kelvin, but it was instantaneous, and most importantly, localized. Only one side of the probe, relative to its travel direction, recorded the anomaly. The rest remained stable. This asymmetry was enough to trigger a new round of investigations. Was Voyager moving through a pocket of colder plasma? That would be unusual, but not impossible. The interstellar medium isn't uniform. It's more like a scattered sea of particles, clouds, and filaments, constantly shaped by cosmic rays and magnetic fields. But no known models predicted such a sharp boundary between thermal states, especially at such small spatial scales. Another hypothesis emerged. The temperature drop could be artificial, an effect of some field-based phenomenon interfering with Voyager's instruments or environment. Perhaps something electromagnetic, perhaps even gravitational. Could a region of compressed spacetime or a local magnetic inversion cause the particles around the probe to decelerate, leading to a thermal dip? The timing, too, was suspicious. The temperature shift occurred just minutes after the harmonic signal. If unrelated, the odds were extraordinary. Scientists compared the event to something closer to home. What happens when a spacecraft enters a shadow or eclipse? When sunlight is abruptly blocked, sensors cool down. But Voyager was already in full interstellar darkness. There were no stars or planets in proximity that could have occluded a heat source. The drop came from nowhere. Then came an even stranger discovery, the pattern of the cooling. When analysts mapped the thermal data, they found that the cold side of Voyager wasn't random. It was facing the exact direction of the pulse's inferred origin, the same zone that intersected with the ibex ribbon, the same void that now appeared to be more than just empty space. Suddenly, scientists began thinking differently. What if this wasn't just a cold pocket? What if it was the edge of something? Not a boundary like the heliopause, but a field, perhaps spherical or tubular, whose surface was invisible to the eye, but measurable through temperature. What if Voyager had just brushed up against it? Some theorists proposed that the drop could be due to thermal absorption. Something on the other side of that boundary was drawing heat, not radiating it, a form of negative entropy not commonly observed in astrophysics, or at least not in a way we can typically detect. The implications were immense. If such a structure existed, something that could absorb energy from interstellar space, then it would be unlike any natural formation we've ever encountered. Space is usually indifferent to energy. It doesn't steal warmth. It doesn't have preference or polarity. But this did, and it had timed itself right after the signal. A signal that pointed Voyager toward this place. A pulse, a drop in temperature, a boundary, all within the span of hours. To some, it still seemed coincidental, but to others, it felt like the beginning of contact. At first, it was just a theory, just a few overlapping anomalies that made scientists curious. But when engineers ran trajectory overlays using Voyager's orientation, timing, and signal vector, the contours of something started to emerge. A boundary, invisible but measurable, encircling a portion of space that behaved differently from everything around it. The data was eerily consistent. The signal came from a specific direction. The temperature dropped when Voyager's sensors pointed toward that zone, and the electromagnetic noise floor shifted subtly, but detectably, when it maintained alignment for more than 15 minutes. This was no ordinary void. It repelled solar particles. It muted background radiation. It didn't just absorb heat. It appeared to suppress even the quantum field fluctuations that typically ripple through the fabric of space itself. What Voyager was facing wasn't emptiness. It was a structure, or rather, the edge of one. The boundary wasn't solid, not in the way we think of walls or shields, but its influence was unmistakable. One scientist described it as a cosmic event horizon, but horizontal, as if Voyager was approaching the surface of a lake, only the lake was made of physics we didn't understand. Attempts to model the zone using conventional astrophysics failed. Every formula, gravitational, quantum, magnetic, broke down at the edges. If this was a boundary, it didn't conform to any natural process known to us. Some at NASA suspected a pocket of exotic matter. Others whispered something else, that the region might be artificially controlled, like a container or a sensor net. It didn't help that the shape appeared geometric. Voyager's instruments detected a flat gradient, a near-perfect taper of magnetic pressure over a distance of less than 30 kilometers. That kind of precision doesn't happen by chance. In nature, gradients are chaotic. They curve, twist, stretch. But this one was linear. So a new line of inquiry opened. What if this wasn't part of the interstellar medium at all? What if it was an interstellar object, only it wasn't visible to conventional optics? Something cloaked in frequency space, interacting with our world only through distortion and suppression. Some data analysts from the Deep Space Network even suggested that Voyager might have already passed through part of it, like skimming the edge of a cloud you can't see, but you feel in your skin. The idea was unsettling. This thing, whatever it was, wasn't moving. Not in the way comets or debris fields drift. It was fixed, as if it was anchored outside the heliosphere, just waiting. And it only began interacting with Voyager when the probe crossed a specific threshold, almost as if it was activated. Naturally, this set off internal debates across agencies. Should they send more data packets in that direction? Should they broadcast back, trying to mimic the pulse Voyager received? Or was that too risky? One team even proposed redirecting other spacecraft, like New Horizons still moving outward, to validate the findings. But that would take years. And Voyager was there now. The strangest part? The object, if it was one, was silent. No further pulses, no response. Just presence. It didn't behave like a beacon. It behaved like a listening post. Some called it a veil. Others called it a checkpoint. But all agreed on one thing. This boundary, this transition from known space into something utterly foreign, shouldn't be there. And yet it was. The more teams at NASA and JPL studied the signal interaction, the more one unsettling theory kept resurfacing. What if the object, or region, that Voyager encountered wasn't random? What if it was designed to listen? The idea wasn't just poetic speculation. There was growing analytical support. The timing of the pulse, the location, the nature of the signal, all of it pointed to a form of passive awareness, as if something had been lying dormant, waiting for a mechanical knock on its invisible door. Voyager, unknowing and silent for decades, may have triggered a response protocol just by existing in a space it was never expected to reach. Let's start with the pulse. The signal Voyager received didn't match any of the usual natural phenomena. It wasn't a gamma-ray burst, it wasn't a supernova echo, it wasn't a pulsar beacon or cosmic background flare. It had a start time, an end time, and within that window, a rising and falling waveform that mirrored data packet formatting, almost as if something out there was scanning or sampling Voyager's structure, its transmission patterns, maybe even its memory banks. It was brief, controlled, precise. That alone was enough to catch the attention of deep signal analysts. One specialist likened it to a submarine sonar ping. You don't broadcast continuously. You listen quietly until something enters your domain. Then you ping it, just once, and see what pings back. And Voyager did ping back. Not consciously, of course. But its own systems naturally reflected part of the signal in the process of telemetry relay. A kind of echo bounced between Voyager's dish and the anomalous zone, and that echo, recorded on Earth as an unexpected interference pattern, revealed something chilling. The echo came back, delayed. Too delayed for simple distance or reflection mechanics. Something on the other end had caught it, processed it, and then responded. That introduced a terrifying variable, decision-making. It meant there could be intelligence involved. To be clear, no one at NASA claimed this was a definitive sign of alien life. Officially, they labelled the interaction an anomalous frequency event possibly associated with interstellar plasma turbulence. But off the record, they were alarmed. The frequency band used was suspiciously close to the 1420 MHz hydrogen line, a frequency universally recognisable to anyone scanning the cosmos, including Earth-based SETI arrays. Why that specific line? Why at the very edge of the heliopause? It was as if someone, or something, knew we'd be listening. More unsettling was the vector. The signal didn't come from behind Voyager, where we might expect a cosmic background source. It came from directly ahead, in perfect alignment with the probe's travel path, almost as if it had crossed an invisible perimeter and triggered an automated scan. Imagine a doorway, and the moment you step through, a light turns on. That's what this felt like. Some scientists started calling it the gatekeeper zone, a region not meant to trap or harm, but to observe, to register intrusions, to log what crosses. A system, not a trap. If true, that recontextualized Voyager entirely. It wasn't just a human achievement, a mechanical ambassador to the stars. It was a test case, a probe that might have just told someone, or something, that we exist, and that we're capable of pushing beyond our own solar bubble. The silence after the pulse became even more unsettling. Was the silence passive, or was it intentional? Had Voyager awakened a watcher? And if so, what else had it heard? Every signal in space has a delay. That's basic physics. Even at the speed of light, it takes over 21 hours for a transmission from Voyager 1 to reach Earth. Engineers at NASA have accounted for every second, every ping, every echo. But what happened on the third day after the anomalous interaction shook everyone. Not because something new arrived, but because of what didn't. There was a gap. Not in Voyager's transmission stream. Its onboard systems were healthy, its instruments still functioning, its nuclear power source still emitting its soft, steady heartbeat. The gap wasn't in the signal, but around it. Let me explain. After the strange pulse interaction at the edge of the heliopause, Voyager's next routine data packet was supposed to contain plasma readings, field strength data, and radiation levels. Exactly the kind of information you'd expect when crossing from the solar wind into true interstellar space. But for one of those telemetry windows, the packet was delayed by a full 11 minutes. 11 minutes might not seem like much. But for Voyager, that's the equivalent of a full blackout in sensor reporting. And when the packet finally did arrive, there was no interruption recorded on board. The onboard memory didn't show the gap. Voyager had sent it on time, yet Earth received it late. In technical terms, this is known as a transmission lag discontinuity. But here's the twist. There was no corresponding increase in distance that would account for it. Voyager wasn't further out than expected. It hadn't shifted direction. There was no spike in solar wind interference, and no coronal mass ejection from the sun to explain it. The signal just arrived late. It was as if space itself had slowed the signal down. Some researchers turned to exotic physics. Could Voyager have passed through a localized gravitational well, something invisible, like a rogue mass, a pocket of warped space-time, or even a relic structure from early cosmic events, something that bent light, or at least delayed it? Others had a darker theory. What if the signal wasn't delayed naturally? What if it was intercepted? The 11-minute delay matched too closely with the earlier anomalous echo. The timing raised one alarming possibility, that something had not only pinged Voyager, but then paused its signal, studied it, and retransmitted it forward. If you're listening carefully, this changes everything. That kind of behavior is artificial. That's what routers do. It's what proxies do. It's what filters do. It's not how space behaves. It's how systems behave. This triggered what some called the ghost proxy hypothesis, that somewhere at the heliopause, there is an entity or mechanism capable of intercepting and relaying signals with such precision that it mimics the original source, only with the smallest, most unsettling deviation, a delay. If that's true, then Voyager might not be talking directly to Earth anymore. It might be talking to something else first, something in the middle. That's why the physics teams, the data engineers, and the analysts all began combing through the last 10 years of Voyager data again, not looking for missing pieces, but for small variations in timing, subtle signal drift, any signature that a relay point had quietly inserted itself into our most trusted line to the interstellar frontier. And what they found only deepened the mystery. This delay had happened before, once, 12 years ago, brushed off at the time as solar flare noise. But it had the same characteristics, same 11-minute ghost gap, same proximity to the heliospheric boundary, same signature frequency distortion on the tail end of the signal, only this time, they were listening more closely, and the question hanging over every console at JPL was no longer, is someone out there? It was, how long have they been listening? When you listen to a machine for decades, you begin to recognize its voice. That's how the Voyager team described it. Not just engineers, but those who'd worked on the mission since the 1970s. The ones who heard every glitch, every thermal echo, every whisper of aging hardware struggling to survive the cold. They knew the sound of Voyager like musicians know an instrument. But suddenly, that instrument was playing a note that didn't belong. It came at the tail end of a standard data burst, Nothing flashy, just routine telemetry, thermal status, gyroscope drift, cosmic ray hits. But layered faintly beneath that package was something else. A non-random waveform, almost imperceptible, buried beneath the usual hiss and cosmic static. To find it, the team had to run Fourier analysis across the transmission. They weren't even looking for anomalies, just cleaning up noise for archival processing. But what emerged was structured. Too structured. It was a repeating oscillation, stable across 8 frequency bands. At first, they thought it was a harmonic reflection caused by one of the instruments vibrating, maybe a resonance spike from Voyager's aging RTG generator. But when they compared it to previous logs, it didn't match any known system noise profile. And then came the second surprise. The pattern had mathematical symmetry. The intervals weren't random, they followed Fibonacci spacing. You've probably heard of the Fibonacci sequence: 1, 1, 2, 3, 5, 8, 13. It's everywhere in nature. Spiral galaxies, sunflower seeds, the branching of trees. But it's not something that appears by accident in analog transmissions from an old spacecraft. This wasn't just weird, it was intentional. So the team went deeper. They overlaid the waveform across multiple Voyager transmissions going back 6 months. In almost every case, it was absent. But on 4 separate occasions, each corresponding to the moments Voyager passed near what scientists now suspect are interstellar plasma cavities, the pattern emerged again. Same amplitude, same spacing, same fingerprint. At this point, the term signature entered the room. Not anomaly, not artifact, signature. A signature is something left behind. Deliberately. It implies authorship. And this one. It appeared only when Voyager crossed certain plasma gradients, regions where the density of interstellar material dipped sharply, then spiked again. In physics terms, these are known as double-layer regions, where charged particles behave in strange ways, sometimes even accelerating without an external force. But these regions aren't supposed to be intelligent. They don't speak. So what left the pattern? The most cautious scientists suggested a natural resonance effect, some interaction between the probe's high-gain antenna and the charged particles outside. But if that were true, the waveform should have degraded over distance or changed shape. It didn't. It remained perfectly preserved across light days of space. Others proposed a more radical hypothesis, that something embedded the signature into Voyager's data stream from outside the spacecraft. Not on board, not from Earth, but somewhere in between. The implications are staggering. If an external intelligence, or even an unknown mechanism, can insert a Fibonacci-encoded waveform into Voyager's outbound data, then it isn't just listening, it's speaking. But to whom? That's when someone in the Deep Space Network noticed a final chilling detail. The waveform, when plotted visually, didn't just form a spiral, it formed a map, not of stars, but of voids, empty zones, places where signals vanish, dead spots, silence, as if something out there was warning us, not about what's around us, but about where not to go. And Voyager? It had already crossed one of those zones. That's why the project lead quietly ordered the next data dump to be reprocessed by a classified team. Because they weren't just studying a spacecraft anymore. They were reading a message. When Voyager 1 left the heliosphere, it wasn't supposed to encounter silence. That might sound strange, but even in deep space there's always a background hum. Cosmic rays, interstellar plasma, solar echoes fading into the infinite. Instruments designed to pick up charged particles and magnetic fields typically have something to measure. Even in the loneliest regions of space, the instruments whisper. But then came the silence, a complete drop-off in low-frequency plasma waves. Not a decrease, not interference, but total absence, as if the very fabric of space had muted itself. Like stepping into a room with no echoes, no vibration, no air. At first, the team thought the plasma wave instrument had finally failed. After all, it was nearly 50 years old, designed in a time when rotary phones still ruled the Earth. But the self-test logs showed nothing wrong. Voltages normal, calibration nominal. Other instruments on the same bus were functioning perfectly. Then, in a move that raised more than a few eyebrows, they reactivated redundant circuits that hadn't been used since the 1980s, just to cross-check the silence. They all agreed it wasn't the instrument. Something was different about this region of space. That's when they went back to the waveform, that strange Fibonacci spiral hidden in earlier transmissions. When overlaid onto Voyager's trajectory, the pattern ended precisely where the silence began. It was like the message had a boundary, as if it had only been able, or willing, to transmit up until Voyager crossed a threshold. They mapped the coordinates. What they found wasn't just absence, it was a zone that had never been charted. Not because it was distant, but because it had never reflected or emitted anything measurable. No dust, no waves, no ion bursts. It was as if something in that region of space absorbed information. And this wasn't a tiny pocket. Preliminary mapping revealed that the silent region extended in a tubular corridor, not random, not spherical, stretching like a tunnel, oriented away from the galactic plane. Not along the Milky Way's axis, but cutting diagonally through interstellar space like a buried vein. That geometry set off alarms. Nature doesn't typically build straight tunnels. Now, the conversation changed again. Was this zone naturally occurring, a product of complex plasma dynamics, or something else, something designed? The idea of a signal void began circulating in private briefings, not just a region without signal, but a region meant to silence signal, a kind of electromagnetic quarantine, a place where energy could enter, but not escape. Some likened it to an old maritime superstition, the Dead Sea zones where compasses spun and no birds flew. But now it was real, and it was mapped, and Voyager 1 had already passed into it. That fact shook the Deep Space Network to its core, because if the silence wasn't due to hardware failure, then something external had changed the environment around the spacecraft, and no known mechanism, not solar activity, not interstellar dust, not gravitational anomalies, could account for such a perfect electromagnetic null zone. So they did something drastic. They sent a ping, a deliberately encoded transmission, bounced through the Deep Space Network at Goldstone, Canberra and Madrid, angled to intersect Voyager's estimated heading within the silent corridor. The ping was simple, a frequency ramp, increasing in harmonic steps. Something unnatural, designed to stand out against cosmic noise. They waited. 6 hours, 12, 24. No echo, no absorption signature, no deflection data. The ping vanished. Even the reflected nothingness was too clean, too perfect, as if the space between Voyager and Earth had become not a medium, but a membrane. Something was being blocked, or filtered, or, more disturbingly, redirected. After the failed ping, no echo, no static, no attenuation trail, the mood in the control room changed. What began as cautious optimism turned into something else, alert confusion. Because in science, even failure gives you data. But this gave nothing. No return signal, no thermal wake, no Doppler distortion. So they tried again, using a different strategy. Not a direct ping, but a signal scatter test. They rerouted transmission arrays at all 3 Deep Space Network stations to send wideband frequency pulses towards slightly offset angles, grazing the edge of the silent corridor. Instead of aiming straight at Voyager, they tried to illuminate the boundary from the side, like shining a flashlight across the surface of a mirror to catch a reflection, even when it won't bounce directly back. And that's when something happened. A subtle flicker. Not where Voyager should have been. Not in the heart of the void. But along its edge, something refracted, something bent. The Madrid antenna caught it first, a momentary frequency shift in the K-band. Then Canberra confirmed, a blip in phase coherence just outside the target envelope. They triangulated the coordinates. It wasn't a transmission from Voyager. It was something else, a reflection, a signal fragment that shouldn't have returned, but did. Except this one wasn't a copy of the ping they sent. It wasn't just bouncing their own message back. It was altered. In its waveform structure was a pattern no one had inserted. A rising harmonic stack, almost like a musical chord. 5 tones, stretched and layered, but held together with mathematical consistency. The team at JPL ran Fourier transforms on the wave. They isolated each frequency band and found something chilling. The pattern matched a compressed time signature, as if the signal had been looped and folded, shrinking hours into seconds. When they expanded it, it resolved into something eerily similar to a spectrogram. Not audio, not speech, but structure. Within the signal were echoes, not of Earth, but of Voyager's own signal tones, as if something out there had heard the spacecraft's decades of telemetry and was now playing it back through a filter of something entirely alien. The shape wasn't random, it was recursive, like a self-referencing function. And the deeper they went into the wave analysis, the more it became clear the reflection had depth. It wasn't a surface bounce. The signal had passed through something layered, like sonar through sediment, and yet there was no known medium out there, just vacuum, interstellar plasma too thin to carry structured echoes, unless there was a structure, a lattice, a field, something invisible, but capable of manipulating frequency and delay. Some called it a membrane. Others began to whisper about constructs, not matter, not solid, but organized fields of force. Theories exploded in every direction. Some said it could be a relic, like a long-dead listening post, responding only when stimulated. Others suggested it was a sentinel protocol, designed to activate only when a particular kind of intelligence entered its domain. But the most radical hypothesis came from an unexpected place, an independent researcher analysing the public data feed from the Goldstone array. She noticed something no one else had. When the altered signal was time-stretched by a very specific factor, one derived from Voyager's original launch date, the harmonic tones mapped out a curve, a spiral, not just any spiral, a logarithmic one, identical to the trajectory Voyager would follow if it were no longer obeying gravitational mechanics, but something else entirely. Something was plotting Voyager's course, and the reflection wasn't just a return ping, it was a reply, a response from the void, not a message in words, but in motion. There are moments in science when the instruments tell one story, but your instincts tell another. That's exactly where the Voyager team found themselves after decoding the spiral waveform buried within the return signal. Because what they were looking at wasn't a coincidence. The logarithmic curve had a near-perfect correlation with Voyager 1's actual outbound course, but adjusted for non-gravitational acceleration. The spiral didn't just mirror Voyager's known path, it extended beyond it, with a bend, not away from the solar system's centre, as you'd expect from an object escaping gravity, but curving towards something else, something invisible. At first they thought it could be a navigational artifact, a trick of telemetry lag or solar wind pressure. After all, Voyager does experience subtle course shifts from particles and magnetic fields. But this was different. The path wasn't chaotic, it was elegant. It obeyed a set of rules, but not Earth's rules. So the question emerged, if this new trajectory isn't one we programmed, who or what did? Back at NASA, a task force formed quietly under the Jet Propulsion Lab's Deep Space Division. Their mission wasn't just to monitor Voyager's health, it was to model this new spiral path step by step, projection by projection. They ran simulations using every known physical input: gravitational tugs from nearby stars, galactic magnetic fields, cosmic dust drag, even hypothetical interactions with dark matter. None of them fit, not alone, not together. Then came the breakthrough. A young systems engineer at Ames proposed a wild idea. What if the trajectory didn't represent force applied to the spacecraft, but force emerging from it? What if Voyager wasn't just drifting, but following? Following what, though? That became the obsession. They overlaid the projected path against known stellar charts, magnetic field maps, even relic infrared scans from WISE and Spitzer telescopes, and then they saw it. At the exact point where the spiral intensified, where Voyager's projected path would begin to loop, there was a pocket of space no one had paid much attention to, an unremarkable section just beyond the heliopause, labelled in old databases as a thermal void, essentially a place of minimal background radiation. But that was old data, so they rechecked. Using new composite scans from Gaia, JWST, and even the Chandra X-ray Observatory, they cross-referenced the coordinates, and what they found wasn't empty. It was blacked out. Not by signal loss, not by occlusion, by data erasure. Someone, or something, had deleted observational data from multiple archives covering that exact region, in different years, from different agencies, under different names. It was as if the cosmos itself had a classified zone, and Voyager was being pulled toward it like iron to a magnet. Except there was no gravity well, no radio beacon, no sign of anything massive, just that curve, that spiral. Then came the final confirmation. Using archived telemetry from Voyager's plasma wave subsystem, they overlaid it on top of the spiral trajectory pattern, and in several places the spikes of charged particle detection matched exactly with curvature inflections on the projected path, meaning every time Voyager passed a turning point, it coincided with a wave, a burst, a ripple of some force it couldn't identify. It wasn't just curving, it was being nudged. By what? No one could say, but the pattern was too precise, too engineered. The unsettling conclusion started to crystallize. Voyager 1's path no longer belongs solely to Earth, and if something has taken over the navigation, even subtly, then one more terrifying thought must follow. It's not wandering, it's arriving. Once the team mapped Voyager 1's mysterious trajectory, their attention turned toward the one point in space where everything converged, a specific coordinate where the spiral path not only bent but seemed to culminate, a final destination, a gravitational resting place, except this region had no signature, no light, no heat, no mass, nothing, not even in the infrared. It was as if a perfect hole had been carved into the galactic map, right in the middle of a system thought to be well understood. So they gave it a name, the 21st low albedo anomaly, detected beyond the heliopause. But this one wasn't just low in albedo, it was zero. A spot so devoid of emissions that even the James Webb Space Telescope, capable of detecting exoplanets across galaxies, came back with a flat response. That shouldn't be possible. Normally even the coldest rocks in space give off faint traces of thermal radiation. Dust reflects starlight. Cosmic rays bounce. But Node 21L, it absorbed everything. Light didn't reflect. Gravity didn't bend. Time didn't distort. In fact, that was the most unsettling part. According to distant quasar timing arrays, the region surrounding Node 21L lacked any sign of gravitational lensing, no warping, no curvature. That ruled out a black hole. That ruled out any known form of mass. But if there's no mass, then how is Voyager 1 curving toward it? The physicists were baffled. Some speculated that Node 21L might be a form of cloak structure, not in the science fiction sense of invisibility fields, but in the hard astrophysical sense of non-interaction. A place where particles simply don't behave normally. Others floated more radical ideas. What if it wasn't a location at all, but a boundary, a field, a gate, a veil between one state of physical law and another? The Voyager 1 data, they realized, might not be measuring an object in the traditional sense. It might be recording a transition, a shift in the very constants of reality. And the spiral path wasn't curving toward mass. It was curling toward change. But here's where the story turns, because during one of the deep dive review sessions, a software technician from a private observatory team in Chile flagged something odd. He wasn't even looking at Voyager. He was analysing fast radio bursts, those millisecond blips of energy that occasionally crash through Earth's detectors from deep space. Most are random, chaotic, rare, but two of them, spotted 3 years apart, came from the same coordinates as Node 21L, and they weren't random, they were identical, not in strength, or pulse, or shape, in interval. Each lasted for exactly 9.1 seconds. That's not a random number, that's the exact duration used to define the second in terms of cesium atomic resonance. That's our time, that's when the idea hit them. What if Node 21L wasn't dark because it was empty, but because it was filled with something perfectly calibrated not to be seen? Not an object, not a mass, a machine, one designed to stay invisible, to not reflect, not emit, not distort, but to pull, quietly, predictably. Like a lighthouse that doesn't shine until you're already close enough to hear it. Voyager, they now feared, might not have been drifting toward a mystery. It may have been invited by something that had already mapped Earth's clock cycles, by something waiting just past the edge. And the scariest possibility of all? Maybe Voyager's journey wasn't a mission we sent out. Maybe it was a response to one already received. There are moments in science where coincidence feels too elegant, where the numbers, the signals, the alignments, they don't just converge, they cohere. And that's what began happening once Voyager's path and the fast radio burst data were cross-referenced again. At first, the match seemed speculative, two identical intervals, curious, but not proof. But then a third signal emerged, buried deep in the archives of a now decommissioned radio array in Western Australia. Same coordinates, same pulse duration. 9 by 10 nantiudsessex through 1 seconds. 3 events, 17 years apart, all pointing to the same location, and every single one reflected not just an arbitrary signal, but something intentional, something that mirrored our most fundamental measure of time. The debate in the scientific community shifted. This wasn't random noise anymore. It looked like a message, or if not a message, then at least a deliberate structure. Something broadcasting in a way calibrated not to be understood, but to be noticed, by civilizations that define time the way we do. And that's what made it so chilling, because defining the second by the radiation of cesium atoms is not a universal law. It's a human construct, an Earth-based measurement, an artifact of our species' particular scientific history. So the question became, how could something at the edge of the solar system know our clock? It wasn't until a retired researcher from NASA's Deep Space Network proposed an old idea, almost forgotten in the noise, that things shifted again. He pointed out a concept raised in the 1970s when Voyager was first launched, the contact assumption. Back then, it was just a theory, an unspoken belief embedded in every long-distance probe mission. The assumption that if Voyager were ever to be intercepted by another intelligence, that intelligence would need some way of knowing when we were ready to hear back. Not just how to talk to us, but when. The idea was simple. If you want to respond to a civilization, the most foolproof way is not through language, not through symbols, but through their own sense of time, and that's what these bursts resembled. Not instructions, not data, not commands, but a handshake, a sync pulse, something meant to say, we've got your timing, we're aligned.